should be considered. And a couple of the reviewers just rejected it. And I still put it in the book, but these ideas of because all the textbooks assume that the only source of energy for the Earth's atmosphere and weather is the sun. And of course, when the textbooks start with that, and then you go to the computer models where they virtually ignore the sun, it's incredible what's going on.
So let me ask you this.
As I said, what we're really doing is we're seeing the evolution of a science, but being blocked by, and I know don't want to get into this part of it yet, but being thwarted by political inputs.
I do want to delve into the IPCC, and I want to talk about a couple of the communication of inquiry or the community of inquiry and the terms of reference, which have to do with limiting the scope of discovery a little bit later. But I want to stay in two more things I want to bring in.
Yeah, just one comment I wanted to make. We're talking about the glaciation, and Bob's bringing forward the fact of the glaciers advancing. One of the big mistakes that's made is that it's assumed that glaciers are only about temperature. And when I did my graduate level classes in climate, one of the first ones, especially the general one on climate change, the first lecture I would give was showing how a glaciation is caused by the Earth cooling. The second lecture I gave was and I proved that how glaciation caused by the Earth warming. And of course, what Bob is referring to and is how quickly you can go into glaciation. But the glaciers are built by snow. Yes, the temperature has something to do with it. There's no doubt about that at certain points. But if you have more snowfall, and enough of it survives through the summer melt, then you are in a cycle of building of layers of snow, which then become glaciation. The mistake that's made is that glaciers are simply about temperature, and the same mistake is being made about tree rings. They assume
What's a tree ring? Wait a minute.
All about temperature.
Hold on 1 second. What is a tree ring?
Tree rings, what it started out was that you cut it through a tree, and you've got these concentric rings. Each ring is supposedly represents 1 year of growth. Originally, it started out as dendrochronology. Dendro is Greek for tree. Chronology is time. And so you're using the tree rings to determine time. But it's starting at the University of Arizona with people like Fritz. And again, I watched all of this evolve. Dendroclimatology developed, where they realized that the width of each ring was an indicator of the weather patterns, but again, it was assumed primarily temperature, and from that you could then reconstruct temperatures of the past. So that became one of the indicators of past climate change. And it's unfortunate it's been so badly abused in what's called the hockey stick, because one of the difficulties we have, Kim, is that we've basically got three periods of climate study. The one is what's called the secular or instrumental period, which everybody assumes gives us very detailed and accurate record, and that's simply not true either. And then you've got the historic, which is human records and observations and so on, and that generally covers about 3,000 years. And then you get into the biological and geological. One of the advantages to tree rings, of course, is that the trees are growing now, but they were also growing before we had instruments. And I worked with people like Peter Scott up at Churchill and Joel D'Aleo, and I had reproduced temperature records for Churchill going back 200 years. Well, they could then take those temperature records, compare with them with the tree rings that they had, and then presumably you could link back. And of course, this is part of the difficulty as well. I mean, we're talking about the mechanisms of climate, but what's really lacking as well is good, long, detailed records, data. And one of the things that's happened, and I watched it in my career and yelled about it but got nowhere, we've got less weather stations in the world now than we had in 1960.
While you're on that, I want to stand by. I want to bring in Joe D'Aleo. Are you there?
Yes.
Could you talk about in our initial conversation you were sharing with me, and I want to make sure I'm articulating this correctly, that there's an organization which took a look at the 1,200, is it 1,200 weather stations?
1,221, yes.
1,221 stations, that basically that they were not kept up to date, that they were not accurate, that they were the primary data for some of the underpinning of what is considered to be global warming. Let me make sure you articulate it correctly.
Well, those stations are in the United States only, although there's some indication that similar issues exist internationally. And it was discovered first by a professor at University of Colorado, Roger Pielke Sr., who did a study of the climate stations in eastern Colorado. And he was very surprised to find that the majority of them were not sited properly. They weren't located in as the National Weather Service's prescribed stations should be located, which is on a grassy surface 100 feet away from the nearest building or trees, open to ventilation, that a lot of these were next to buildings or on concrete or on rooftops or next to air conditioner. So he published on that, and that got Anthony Watts, who was a meteorologist in California, interested in looking at that problem, and went to look at a few stations in California and discovered that indeed was the case. And he decided to start a volunteer network of meteorologists, climatologists, other scientists interested in the issue to go and investigate all 1,221 stations, take photographs from all directions, use satellite photography to look from the top, and document the sighting of these stations. And they were surprised to find many were on concrete, on roads, in parking lots, on rooftops, next to air conditioners, in waste treatment plants. And in fact, of the 1,221 stations, they've currently surveyed about 1,000, and 90% of them they found to be poor or very poorly sited using the government's own criteria. And in all cases, the siting favors a warm bias, virtually all cases, of more than a degree Celsius or say 2 degrees Fahrenheit. So that is certainly a contaminant to that data. But that's only one. Tim mentioned the big dropout of stations globally that took place around 1990. In the 1960s and 70s, we had about 6,000 stations reporting. After 1990, it dropped to less than 2,000. In fact, in the last year, in most months, our data centers are using about 1,000 stations. So 80% of the world stations are not being used.
Why?
And well, some of them dropped out with the fall of the Soviet Union, probably because of inability to continue to support them financially. But it appears that in a lot of cases, it's our governments and our data centers not going after the data. In Canada, for example, we have very few stations in the global databases. We do have big holes also in Brazil. And most of Africa is missing, large holes in Australia and in the former Soviet Union. So we're at Greenland.
I have a question for the lay audience, which includes me. Why would we depend today on these stations, these separate stations? Why can't we just do everything by satellite and look into real weather or climate via satellite and get our information?
Well, we do, actually. We do have satellite microwave sensing of the atmosphere and lower atmosphere since 1979. And we believe it is more accurate than these stations globally, the station databases, that in addition to the stations that disappeared, in a lot of the other stations, it was a tenfold increase in the number of missing data inputs or months. So there were big holes in that data. But we do have good satellite data going back to 1979, but because it doesn't go all the way back to the 1880s, it is not used by our governments when they do their long-term analysis. It should be. It is a better data source than our station database.
So when we get the news about weather, where is it emanating from? What is tracking the weather in different parts of the world then?
Well, certainly, there are data centers that are responsible for assessing on a monthly basis the state of the global atmosphere in the U.S., also the U.S. NOAA